Okay, let's talk about 10.5, which covers the topic of tangent and intersected chord theorem. So a tangent and intersected chord theorem. If a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is half the measure of the intercepted arc. So let me just draw that for you, what that means. So we have a circle here, and then we have a tangent line down below. And let's say this is the chord where it meets up the tangent line. And then we have angles 1 and angle 2. Angle 1 being over here, and angle 2, we'll say angle 2 is this, and angle 1 being on the other side. Angle 1 being on the other side of that. We can then say, let's label these points. So let's label the point, this point A, this point B, and we'll label this C. We can say that measure of angle 1, that small one, is half of AB. So 1 will match up here with AB, is equal half of measure of AB. Whereas measure angle 2 is in half of this side right here. So measure angle 2 is half of measure angle arc ACB. Okay. Next one, so let's try that. So we want to find CD being right here. If this is 65, CD is twice of that, because it's half of the arc. Arc then is twice. 65 times 2 is 130. We want to find measure angle 5. Measure angle 5 here. So we need to find this. We need to find this. This is 230. The entire circle is 360 degrees. Or we can say, if that's 230, this angle here next to angle 5 has to be half of 230, which is 115. That means 5, to find angle 5, we take 180 minus 115, which is also 65. Measure angle 3 is here. Same thing here. If this is 220, this then has to be 110. 110 plus what makes 180? 110 plus 70 degrees. So measure angle 3 is 70 degrees. BDC, I can already tell. This is half of a circle. I don't even have to do anything. Half of a circle is a semicircle. It's 180 degrees. It's 180 degrees. So measure angle 3, and this is 180 degrees. Next, our theorem, the angles inside the circle. So if two chords intersect inside a circle, then the measure of each angle is half the sum of the arcs intercepted and its vertical angle. So let me draw you what that means. So if I had a circle and there's a vertical angle inside, let's say this and this, and we call this A, B, D, C, and we'll call this angle 1 and angle 2. Angle 1, we'll coat that with red. These vertical angles or arcs are red, and angle 2, we'll coat that in purple. So 2 is purple, 1's red. And I can say measure angle 1 equals half of AD, the red part, measure of AD plus the measure of BC. Whereas measure angle 2 is half of measure AB plus measure of DC. Going on further to the next idea is the angles outside the circle theorem. So if a tangent and a secant, two tangents or two secants intersect outside a circle, then the measure is formed by 1/2, not the sum this time, the difference. If I draw a circle here, show you what that means. If we have a line that cuts through the circle, this being a secant, and then a line that kind of touch it, this being a tangent right here. And we call these A, B, and C down here. Call this, or if we had another circle, erase that, if we had another circle, and they had two tangents, so this one here, this one down here, we'll call this P, we'll call this point Q, call this point R. And then finally, if we had two secants, meaning two lines, that cuts through the circle, we'll call this W, X, Z, Y. And this will be angle 1, angle 2, angle 3. I'll color code this. So the outside part, we'll color code in red. So these are the outside, the larger arcs. Inside, we'll color code those in purple. The smaller arcs, if you have this, you basically take 1/2 the larger arc minus the smaller arc. So measure angle 1 equals 1/2 measure BC, so the bigger one, minus AC, the smaller one. Same thing, measure angle 2 equals 1/2, the bigger one is PQR minus the smaller one, PR, or measure of PR. And then measure angle 3 equals 1/2. We can say the bigger one, XY, smaller one being WZ. So the bigger one, subtract the smaller one, divide by 2. That's how you would find it. Next, a circumscribed angle. So circumscribed. A circumscribed angle is any angle whose sides are tangent to a circle, and the measure of the circumscribed angle is equal to 180 degrees minus the measure of the central angle that intercepts the arc. So if we had a circle like this, here's the central, and then let's say we have the two tangent lines here and here. Call this A, D, B. The circumscribed angle is this one right here. It is kind of like angle 2. It is also, so if you don't know the arc lengths, but you know this angle, we can say that measure angle ADB is 180 minus ACB, angle ACB, the measure of angle ACB. All right, let's put this into practice. So number 5, X is in the center. X equals 1/2 50 plus 90, 92. So this 50 plus 92, got to be half of that. Plug that into the calculator. X is then 71 degrees. Number 6. This 38. So 38, and this is x. The x now is the arc, so we got to still use our formula. So our 38 is then 1/2. Now this is subtraction, the big one, which being x, minus 72. Now I just got to solve backwards. We're going to multiply both sides by 2. This cancels out. So then that gives me 76 equals x minus 72. Add 72 to both sides. 148 is how much x is, 148 degrees. This one, what is x? X is 73. That's just a given. That's 73 degrees. Number 8, x here, x equals 180 minus 130, which is 50 degrees.